Okay, Paul here, and today on the bench I have this 16-inch Emerson fan that was sent in to be checked out. The problems that I noticed with it are numerous. One is dent there in the cap. The wires are bent here where it connects, and you can see the cage is bent. But those are minor compared to some of the other problems. One, the column here is totally shot. I just took it off. It's got cracks in it. If the camera will focus, you can see the cracks here. And cracked at that screw there. Cracked right through over here, as you can see. And so it's missing the third screw, which went here. And you can see it's cracked next to each of the screws. So what I'm thinking, and it's cracked there, there, and there, and there, of course. What I'm thinking is I'm going to try to find one online, and in the meantime, while I'm waiting, if I can find one, great. If not, I'm going to compress this back to where it goes after I put some JB Weld in there, and I'm going to reform this just solid with JB Weld. And I think the 2 screws should be sufficient enough. It basically holds the fan on the base, is what that's for. And it also runs the oscillator arm. So it's got to be stationary on here, has screws that go in that stop the fan, the motor from coming up. And actually there might be another way to keep that motor on there, but we'll think about that one. And right now I just want to basically make sure it's going to work. So I started taking the took the connector off with the grommet for the head wire, so we can hook up temporary power cord and see if the fan even runs. Check the resistance first, of course. Then we'll check the resistance in the speed coil and see what we got as far as the electrical, and then go from there. So bear with me as I strip these, and then we'll do a test, an electrical test, and see how that goes. Okay, I'm across 2 wires of the head wire. You see I took them out, and I've got 20 ohms there. So we'll call this number 1, number 2, number 3, or A, B, C. And I'll leave them in that order that they're sticking out. So let's try A to B. Okay, for A to B, we got 37 ohms. Let me write these down. I'll find my pen. And here we go. I'll put these down on this paper here. Let me move these wires. Give me some room to write. Okay, so we got A to B, 37 point, we say 37.2 ohms, 0.2 ohms. So B, A to C rather, and then B to C. Okay, so let's do A to C, and from A, and don't touch that, to C, we have 55 ohms, 55.1, 55 ohms. It's going to drop as it sits there a while and fluctuate because I'm using a cord, but it doesn't matter. We just need to know roughly what we got. So we got 55 ohms B to C, A to C. Now we'll do B to C, which I had already done. And on B to C we have about 24 ohms. And it's dropping. Let's let it settle down a little. All right, we'll call it 22 ohms. Oh, maybe not. 22.5. Okay, so there's our head voltage, head resistance between the wires. A to C 55, B to C 22.5, and it still is fluctuating. I don't like that. I shouldn't be moving. So the rotor is inducting the charge into the coil. All right, so again, that's B and C. We got roughly 19 ohms. Seem to stabilize there. That's better, 19 ohms. Okay, well, 22 is fine. Doesn't matter what we call it as long as we know what one it is. And let's do the A to C again. And we'll do A to B one more time. 35.7. Okay, that's doing better. Okay, so 35.7 from A to B. And I had 37 before I let it set in, so we'll call it 35.7. Okay, I still don't like the A to C being only 50 ohms. This is a big fan, but maybe that's right. For a 16-inch fan, that could be. It would take more power, so you would have less resistance, so you're using up more wattage. Let's see what it says it's rated at. If I can get a light on there. Can't see it. Hold on a second. Blind person needs his eyes. Okay. Man, that's really worn out. Get that light back up there. It's really worn out. I can't see it. It's the one box. It's this box right here, right under the type number, which by the way is, wet that and see if I read it better. 73, 64, 648. Might be 78, 648. And the number, let me see. The number, can't read the first letter, 67, 37, 6. 67, actually, that's a 5. 6, 7, is that a 5? Yeah, 67576. And there's a letter before, oh, T, okay. But the speed is totally not even there, so they never etched it. They also don't have the current listed. But I know it's going to draw a little bit of current because it's a 16-inch fan, so I don't know how much of that you can see, and I apologize for moving the camera around. I'm trying to read it and adjust it at the same time. Okay, and that's what we have so far. So let me go ahead and try to figure out where to run the power to on this one. I'll probably pull the base off in the fan and see. At least now we know that the motor has coils showing resistance. There's no opens. Whether or not the resistance numbers are in the right ballpark remains to be seen, but I think they are because it is a big, hefty motor. So it might be fine. The little 12-inch motors just don't use as much power to spin as this one would with these blades. So we'll go from there. Thanks for watching. Okay, I'm taking this speed coil out of the bottom. And that was like that. So this wire was up at the head wire. Yeah, okay, good. So that helps. You know, the motor came in, but the wire is totally gone. But it's nice when they come back in, and somebody had reworked on this one, but it's nice when they come back in and they're in where they belong, because then I know that don't look too great there, but maybe that's just shellac. Okay, yeah, then I know, I don't have to spend a minute or two trying to figure out which wire goes where. I can see it. So basically, we got 3 wires here that go to the speed switch. So there's off there. That's most likely low, medium, high, I believe. And there's no information on this. It's totally gone. So thinking it's low, medium, high, but the resistances will tell us that. And since this looks like it's probably shorted, we may get some funky readings till I strip that, but let's just do a rough check. Let me get my voltmeter back. I mean the ohm meter, or digital multimeter. All right, go back to the resistance scale, and to get a little accurate reading, I'm going to go ahead and zero it out, because I am using these connectors, jumper cables. It just makes it easier while I'm holding the phone. Okay, so try that again. Okay, so now we're zeroed out. So we'll put this on this one, and we'll check across low. Low is 1 point, there's a lot of glare there, 1.6 ohms. Let me see if I can move that in a better place. Try that again. Is it shorting out on me? It shouldn't be. Okay, so low is, hold on. I think my zero out went off when I moved it, so let me go ahead and re-zero it. Okay, try that again. That makes more sense. 1.6, and on the center tap of the coil, 1.3. And so between 1 and 2, or first 2 parts of the coil, 0.6. So, okay, so 0.4, 1.6, 1.7. And if I subtract this from 1.7, I should have around 0.4, and I do. Okay. So the coil's good, and the motor coil seems to be okay. There's no capacitor in this fan, which is unusual for a 3-wire fan not to have a capacitor. I need to definitely pull up this model number because this should have a capacitor. It's also missing the screw for the oscillator here. The oscillator arm is just dangling here, but the screw is not in it. So we got that to deal with too. That's not a biggie. I just got to find a screw that'll work. It won't be an original screw. They're just not possible to find. Okay, so we got to find out if this is supposed to have a capacitor, and I believe it is. Running capacitor, but I'll check. Who knows? Maybe on this particular model they didn't use it. But okay, but I'll check and see. Okay, here's this Emerson fan with the speed control figured out, and I got it wired up to the correct head wires. So now I got it all operating correctly. And this thing is a turbine. I'll put it on low. You're going to hear a lot of noise, so just be aware of that. Look how fast that thing spins. That's low. Medium and high. Now it's on high, you'll hear it slow down when I drop it down. Medium. Low. And it still picks up speed. Okay, now it is drawing on high at 110 volts, almost, well, a little over 3 amps. And then it drops down and it levels out about 2.75 amps. It's still dropping just a little. That's a lot of amps, but the fan is wired correctly. I verified it a few times. In fact, it won't even run on all 3 speeds. It won't even run unless it's wired this way. So it's wired correctly, and that has to do with those low voltages, ohms resistance that we measured previously. When I first measured the resistance, and I was getting roughly 35.7 volts on one part of the coil, the motor stator coil, 50 ohms on another, and 22.5 ohms on another. Those are low numbers, but because they're low numbers and you have a heavy fan and a big motor, it draws a lot of power. I can't find the specified amperage for this fan. Now, bear in mind, I haven't oiled it, greased it, cleaned it, or anything. I just got it working. And on here where they have information about the speed, it's not there, and they don't have anything about the amp draw on the fan badge. So, it's pretty high, over 2 amps, almost 3 amps. That's a lot of current draw. But this thing is a turbine. It throws a lot of air. But we'll see what happens with the current once I get it greased and serviced. But I wanted to do this part of the video, so that the customer could see the fan, see that it's working, get an idea of what's involved in it and where we're at with it. So anyway, I appreciate you watching the video. I hope you found it informative. If you have, please consider giving me a thumbs up. I appreciate your support. If you got questions, please leave a comment. But yes, I appreciate any support you may provide. And subscribe to my channel if you find these interesting. I do a lot of videos on antique radios and antique fans, as well as small appliances. And I'll be starting to do some on CB radios as well, so ham radios. So anyway, I appreciate you watching the video and I appreciate any support you may provide. Thank you.